Traditional web apps ship fast and patch later. Blockchains can't afford that luxury. Once your bytecode is on mainnet, upgrading is painful, governance-gated, and often impossible. Worse, an attacker doesn't need insider access. Every line is open source, every function signature public. The only sane strategy is to make the test suite your first auditor. Move's deterministic VM and the built-in prover mean every test run is reproducible byte for byte, so a green bar locally is a near guarantee of identical behavior on chain. Unit tests are your tight feedback loop. They compile straight into a private VM where each test starts with a blank ledger. Because nothing touches JSON, RPC, or signature code paths, they finish before you can Alt-Tab. Use them for arithmetic, boundary checks, and helper functions that don't require multi-actor choreography. The standard macros mirror Rust, assert, for booleans, assertec, for value comparison. A failing assert aborts the whole test, printing your error code so you can jump directly to the guilty line. When you need to verify that Alice really can't steal Bob's badge, or that two independent calls increment the shared counter correctly, unit tests are not enough. Scenario tests boot an entire validator swarm in RAM, obeying the same rules as DevNet. You mint test SUI from a built-in faucet, craft transactions, bump the simulated block height with nextText, and finally assert on object storage or event logs. All of this still happens before disk I/O, so iterations remain lightning fast. A healthy suite proves not only that good flows succeed, but that bad flows fail in the right way. Maybe your cap is missing, maybe total supply would overflow. Either way, the user should get a deterministic, well-documented abort code. Mark those cases with YAML expected failure, abort code equals ECODE. If future refactors accidentally change or remove the assert, the test turns red and your CI blocks the merge. Error code contracts are how wallets and indexers translate cryptic numbers into clear UI copies, so don't treat them as throwaways. Real contracts juggle many actors: a marketplace listing, a buy order, a fee skim. Each involves at least two wallets and several objects. Scenario helpers let you write those flows like a screenplay. Alice mints, Bob buys, market takes fee. Because the harness exposes event sequence numbers, you can verify that your reentrancy guards and write locks behave exactly as the whiteboard promised. Unit and scenario tests check the paths you thought of. Fuzzing checks the rest. With property-based testing, you state high-level laws, the supply never dips below zero, and the harness bombards your entry function with randomized inputs looking for a breach. One Saturday afternoon of fuzzing often replaces weeks of manual edge case brainstorming, especially around math or loop logic. While Move's core toolchain doesn't bundle fuzz yet, open source crates plug the gap effortlessly. A flaky manual test run on your laptop isn't DevOps. Wire the CLI into CI, download the CLI binary, check out the repo, run both unit and scenario suites, then export coverage. Browsing the HTML coverage report instantly shows which assert. Lines never run. Finally, wire Move prover into the same pipeline. If an upgrade breaks a previously proven invariant, the build turns red long before users notice. This pair nails the two extremes. We spin a scenario, initialize the singleton, mint within the cap, and assert that total supply increments correctly. The second test tries to overshoot by one. Prover says it should fail, and expected failure confirms exactly ECAP overflow. If a future dev optimizes the overflow check away, this test flips red and the pull request blocks instantly.